All right, so chapter 2, section 4 talks about continuity of a function. So, in order for something to be continuous at a given point, you have to have all of three of these things work. So, the function at the point A has to be defined. So, if it's undefined, you've got a problem. The limit of f of x as x approaches a must exist, and the limits as x approaches a of f of x has to equal its function at a. So the first two aren't really an issue, but the last one, say you've got this function that got a little hole here and keep going up or whatever, and the actual function at this point, whatever a, we'll call this a here, is something different. This is not continuous. You've got a hole in your line essentially, and that's a problem. Even if you've got this now, if this dot instead fills up the hole, then we're no problem. All right, so theorem 2.8. This is something we've already talked about. Polynomials are continuous at every point in their domain, as are rational functions. So now a rational function may not have a domain, have a hole in its domain if there's a zero problem, like say 132. 132 is a rational function. However, so if, well, no, this is going to be no problem. All right, so this one is fine. If instead this was, say, -1, x squared minus 1, then when x is 1 or -1, we would have discontinuity. This one's fine. This is continuous everywhere. This one, however, is discontinuous at x equals 0, because then we have a 0 in the denominator.